This is a tutorial video for my simulation on artificial gravity. And when I used to teach this class, kids would always ask me what happens if you jump when you're on a rotating space station. So I created this simulation to show that. And when you load it up, you've got this little astronaut standing on a rotating space station. You can see that this is currently set to 1G. You can modify the radius of the space station, and that will obviously change the G's if you don't change the speed. You can change the speed of the space station, and you can change the astronaut's jumping speed, which we're going to get to in a second, as well as his size if you want to zoom in a little bit. But I usually keep him at 1.8 meters tall, which is a good average height. If you go down here to the Earth button, if you click that, it will automatically adjust the station speed for the size of the space station, for the radius, to give it 1G. Likewise, Moon will give it 0.17 Gs, and Jupiter will give it 2.5 Gs. You can also adjust the simulation speed, and you can zoom in and zoom out to some extent if you like. So in order to show the jumping, I'm going to go to Earth here to give it 1 Gs, and I'll just give him a jump. And you can see, of course, in the absence of real gravity, as soon as he leaves the floor, he will move in a perfectly straight line according to Newton's first law of motion. So when you're jumping, you're just maintaining the tangential velocity from the rotating space station, and I'm giving him a small component of perpendicular velocity, so he reconnects with the floor a little bit further on. And you can see that in this situation, you do reconnect with the floor fairly close to where you leave the floor. But if I give him an exaggerated jumping speed like 6 meters per second, he'll actually land quite far ahead. So the amount you land ahead is really dependent on how many G's you're currently experiencing, and the size and how fast you can jump. On something like Jupiter, even with an exaggerated jumping speed, because it's 2.5 G's, he still lands fairly close, although a little bit ahead of where he left the floor. And of course on the Moon, he lands very, very far ahead, which makes sense because if the speed was 0, he would land exactly halfway across that circle. So what's interesting, I think, about this is that from the astronaut's perspective, he would feel as though he's jumping straight up, but he would see himself land ahead on the floor. And we get something similar if you throw a baseball. So if you click reset, it will reset the trails of the jump. Now baseball will have him throw a baseball. And you can click on this button, Show Aim, and you'll see 2 new lines. The white line is the direction that he is aiming, and the pink line here is the direction the ball will actually end up going. So in this situation here, he is aiming directly upwards from his perspective. Maybe we'll even slow this down. He's aiming directly upwards from his perspective, but if he releases the ball at this moment, it will actually travel horizontally because of that motion of the space station. So perhaps I'll throw it here. If I throw it right here, it should hit the space station near 3 o'clock. Okay, maybe I'll just redo that. Say now. Anyway, you can see it doesn't actually follow where he's expecting it to go. So from his perspective, he's throwing it straight up, but it's actually landing in front of him. And if you wanted to actually throw it straight up and have it land on you straight up, you'd actually have to throw it backwards. I'm not sure what amount is going to work. Oh, that was pretty close, actually. So there you go. You'd have to actually aim backwards to throw it to himself. I'll reset. The last mode, I kind of added a hot dog stand here. And the goal here is for the astronaut to throw the hot dog and to have it land in the hot dog stand. But unfortunately, there's no real intuitive way I can figure out to do this. It's really just a guess and check. I'm just going to make him fly to the other side here. So, I have no idea if, it's going to land. You can always make him throw it, I guess, exactly backwards, and it will kind of hover in place until the hot dog stand gets. Oh, I still missed. The kids get a kick out of this, especially if it takes up 20 minutes of class time. And oh, that was really close. Let's try 173. And there you go. Cool. I hope you enjoyed the simulation.